So our next speaker is Rafal Mastyna from CERN. He's an automation engineer working in the instrumentation section of the cryogenics group. He's in charge of the integration of Ethernet-based field bus in the existing cryogenics cards for measurements, temperature, pressures, etc.
Okay. So I would like to talk about the PROFINET communication card for cryogenics. At the beginning, I will do some general introduction, then I will show the system architecture, development, and finally I do the conclusion. On the left-hand side, there is architecture of our system. It consists of crate, which is remote I/O. That's device for collecting the sensor signals from the sensors like temperature sensor, pressure sensor. It connects with FEC, which is a front-end computer, through the word FIP. We use word FIP because we work in radiation areas. Also, all the calculations are performed on this front-end computer because we didn't want to do any calculations in the radiation area. Then the data is sent to PLC and to the control SCADA, and that's the main path of control. Apart of this, we've got configuration SCADA with configuration database, and we also log data to perform cloud analysis. For non-radiation areas, we decided to change a little the architecture to use more intelligent I/O device. We moved the calculations from front-end computer to our device, and also we use another protocol, PROFINET instead of word FIP, and what's more, we use OPC-UA, and it allows us to connect directly to cloud data system instead of using the database. A few words about the crate. As I said, it's a device for collecting the data from sensors. So we've got sensor cards, heater cards as actuators, and communication cards for communication with our control systems. That's the general overview of prototype. Initially, this crate was done, the prototype, on Bern University. The main parts are FPGA for collecting the electronical signals, and NetX chip for doing the calculations, because, as I said, the requirements were calculations on the card and simplification of the architecture. Our develop consists of three main domains: is IT, automation, electronics. In IT, we usually use NetX chip and Quasar C++. I will tell it about later. Automations, we use classical PLC, and electronics, we use stuff like Altium Designer, VGDL for program the FPGA. Inside the crate, the data is collected by FPGA, then is sent to the NetX application. The NetX application is multithreading application. It consists of several threads. The data is sent from one thread to another. Then some calculations are done, and different types of data is sent according to the destination to different protocols like OPC-UA, PROFINET, and to some visualization on WEBSERVER. Because our device is not standard device, in order to integrate it with regular PROFINET architecture, we had to write our configuration and description files using the HTML file description. So now our users are able to easily integrate it with Siemens and other stuff. They are able to integrate it with Siemens with the PROFINET software. Very important part of our project was to integrate our crate with our configuration SCADA, and we decided to use OPC-UA. Initially, the best idea was to use direct connection, but so far, for our microchip, the library for OPC-UA is not available yet. So we decided to do another solution. We did a middle layer. We use Quasar framework. It's a framework which is developed at CERN. It creates OPC-UA server. We connect to the server through the socket, and we set up Quasar on CERN OpenStack, so it's available all the time. For more details about the Quasar and OPC-UA at CERN, I recommend to visit the poster and read the paper of Benjamin. As I said before, we do some cloud analysis, initially using the database for logging. We connect to this database every day, and we do some queries, then we store data in Elasticsearch, and finally we do analysis in Kibana. But because of the fact we've got intelligent device, we can connect directly with the cloud data analysis, and it's more simple. For more information about the Elasticstack, please refer the poster of James and read this paper. Cloud data analysis is useful because it allowed us to find some problems, some errors, for example, with temperature or with protocol connection. So it's really useful for us. As I said, the initial board was projected at Bern University, but we had to do some minor changes in order to do the conclusion. The new device, the new communication card, simplifies the architecture because we do not have to use another device for calculations. It also supports the standard PROFINET protocol, and it allows us to connect directly with cloud data analysis. I would like to thank you, ITER, for initial support of development of our project, and I would like to thank also to Benjamin and Michael for support with Quasar project, and to James for support of Elasticsearch. Thank you for attention, and please do not hesitate to ask questions.
Time for questions. I know that the room is cold, but you may have any questions, no? Okay, I have one just for breaking the ice. So you have experience now with this development of special chips, netics. What is your opinion in terms of easiness of development to integrate, for example, any electronic card to a field bus, like a PROFINET? Is it easy? Is it something that is very tedious, or is?
It depends, because I had to look at the protocol from the programmer point of view. So I had to use the API and stuff like this. So it depends, but it's more or less quite easy.
So I have one other. The Kibana product, is this in-house or is it a commercial off-the-shelf product, the Kibana?
Kibana, yeah. I think it's open source.
It's open source. And it's a data analysis suite? Okay.
Any other question?
Just one minor question. Do you actually use a cluster for your Elasticsearch?
Can you repeat?
Do you use a cluster for your Elasticsearch, or is just one box?
No. Cluster? Cluster. I'm not actually sure about it, because I'm more focused on my device. I mean on crate and communication cards. Another group is responsible for the cloud analysis. So the best idea would be to ask James from the poster, because he's expert in this area.
Okay, thanks.
You are lucky because James is over here, don't worry. You can ask him who is it, don't worry. Any other question? Okay, so let's thank the speaker again.